Hello viewers, we're now taking you through the story for A-level pure mathematics, and this video we're going to go through the marking guide for senior 5 of end of term 3 2022 for one of the schools where I happen to be a teacher. So this video is suitable for students in both senior 5 and senior 6 offering mathematics as part of their combination. So question 1 says, without using mathematical tables or calculator, find the value of this expression. So yeah, the first thing to realize is that there is difference of two squares. So shall work on that. So we shall say this minus this gives you the difference which is here, and then when you add you get the addition which is there. So next is collect terms. You realize that this cancels and this cancels. So for this first part, you remain with this and this, which is negative 4, and you remain with this plus this, which is 2 root 5. Then root 5 cancels, and also this cancels to give you negative 1 as the answer. So as brief as that. Question 2 says, find the angle between the lines this and that. So for that line, the gradient is this. So gradient is going from here, quotient of x. Then for this line, we shall rearrange and get the gradient as negative 11 over 2. Then from there, we shall remember the formula for angle between two lines. Tan theta is equal to m1 minus m2 over 1 or plus m1 m2. It should be in magnitude sign. So we shall substitute for m1 and also for m2, and we shall come up with that. So magnitude means what is negative becomes positive. Therefore our theta will be 36.87. Then question 3 says, find the gradient of the curve this at point this. So that is an implicit function which you have to differentiate on both sides. So differentiating x squared gives you 2x, differentiating 2xy, the 2 can first come out, then you differentiate xy alone. Differentiating xy gives x dy dx plus y. Then differentiate this gives you 2y dy dx, and this gives you 1. This gives you 0. Then from there is to make dy dx the subject. So that will be the gradient function, but they want the gradient at this point. So at that point, the value of x is negative 4, and the value of y is 1. Therefore, come and substitute for x as negative 4 here and here, and y as 1 here and here. You will come up with negative 0.5 as the gradient they wanted. Then question 4 says, the area generated by y equal to 5 and the curve this is rotated about the x-axis. Find the volume generated. So we shall need the intercepts of the curve. When x is 0, y is, come and substitute for x here to come up with y equal to 1, therefore the coordinate is that. What about when y is 0? Still substitute 0 here, you'll come up with x squared, so this shouldn't be here. So x squared plus 1 equal to 0. And that means that x is undefined because x squared cannot be equal to negative 1. Meaning that it has no x-intercept. What about the points of intersection? So the point of intersection, we shall equate this and this to come up with that line. Then look for a way of making x the subject. So x is plus minus 2. So shall come and make our sketch. We need the axes well labeled. So this question is not about curve sketching. We are just making a sketch to easily get the volume generated. That's why you are not seeing us getting the maximum point, turning point, those things, and the nature like that. So here we shall just look at this equation. It has a positive coefficient of x squared, meaning it is in this form with a minima. In that form. Then shall come and substitute the intercept. It is here. Then you also need this straight line. Y equal to 5 is a straight line. So this should be 5. You can edit it. Then at this point of intersection we have negative 2. And this point we have positive 2. So the area they want is the area enclosed by this. It is one which is rotating. But remember, we are rotating about the x-axis. Therefore, the element of volume we should come up to be in that form. A hollow cylinder with thickness delta x, which is here. So you shall have the radius of the small cylinder, which is y1, and radius of the bigger one, which is y2. So to get the area of the shaded part or the volume generated, it will be volume of this bigger cylinder minus volume of the smaller cylinder, because it is hollow. So you come and say that volume will be equal to pi integral of y2 squared minus y1 squared dx. Then you substitute y2 was 5, it is squared. Y1 was x squared plus 1, it is also squared. Then you shall first expand. Expanding this gives you this. Then collecting like terms for the whole gives you that. Then when I integrate, 24 gives you 24x, x power 4 gives you x power 5 over 5, 2x squared gives you 2 over 3x cubed. Then I'll substitute the limits. Begin with the upper limit. Where there is x, you put 2, as you can see here. Then substitute the lower limit. Where there is x, you put negative 2. Then you shall use a calculator to simplify. This is 48, this is 32 over 5, and this is 16 over 3. This is negative 48, positive 32 over 5, 16 over 3. Then I use the calculator. The whole of this is 544 over 15, and the whole of this is negative 544 over 15. But negative and this minus gives you a plus. So when I add everything, I'll come up with this as the volume generated. That was question 4. What about question 5? Question 5 says the roots of the equation this are alpha and beta. Find the values of this and that. So from this equation, we shall first get the values of sum and product of roots. So dividing 12 by 3 gives you this, and therefore sum is negative of this, and product is the whole of this. Now I can go to part A, where they want you to get the expression of this. So get the LCM to give you this. Then this numerator is a sum, denominator is a product. So when I divide the two, I'll come up with 4 over 5. Then for part B, this one, it's a common expression. It gives you this. Then you substitute for sum and for the product. Then you can get the answer they wanted. Question 6 says solve the equation this equal to this for, now you should realize that the angle is in radians. So I'm going to first rewrite the given equation. Then from here I'm going to take the whole of this side to give me this. Then from here I realize that this cos theta and this cos 4 theta are common, so factorize it out. Here I remain with cos 6 theta and here I remain with cos 2 theta. Then this one, using factor formula, I'll come up with negative 2 sine this plus this over 2 to give you 4 theta, and also sine this minus this over 2 to give you 2 theta. Then take everything the other side to come up, take the whole of this, because this is now negative 2 sine 4 theta, sine 2 theta, cos 4 theta. Take this side to become positive. Then sine is common. Now here, some students at this step, they would think they would cancel this and that. So that is not allowed in trigonometry, so never do that. What we need is to factorize. So here, sine 2 theta, sine 2 theta, factorize it out, get what is remaining. So this one, from double angle identity, it becomes this. So either this is equal to 0 or this is equal to 0. For this equal to 0, 2 theta is 0 degrees, therefore theta is 0. But remember the angle is in radians. Okay, for this equal to 0, 8 theta is 270 and theta is that when I divide by 8. But remember the angle is in radians, so I'll come and change from degrees to radians by multiplying by pi over 180 to give you that as the answer. So question 7 says, using small changes, show that 244 to power 1 over 5 is equal to this. So shall I say that let the expression of this be equal to y plus small change in y. So y plus small change in y will be equal to x plus small change in x to power 1 over 5. And from this can be written as 243 plus 1, where this is that and this is this. So why are we using 243? It is because if you press your calculator, 243 to power 1 over 5, you come up with an exact value which is 3. So if this is equal to this, it means that y will be equal to x to power 1 over 5, which is 243 to power 1 over 5, and it is 3. And small change in x is 1. Okay, so now you have got the value of y here, but we don't know the value of small change in y. So you come and say that first of all, dy dx is equal to this. So when I differentiate this, I'll come up with this. Then I substitute for x to come up with the value of dy dx. Then from there, remember that small change in y approximates to dy dx times small change in x. So come and substitute for dy dx, which is here, and small change in x, which is here, to give you 1 over 405. So now that I have the value of y and the value of small change in y, I can easily get this value. So come and substitute for y and small change in y to give you this as the answer, and that is what they wanted. Question 8 says the straight line this cuts the curve this at P and Q. Calculate the length PQ. So you have to first get the points of intersection. So for this straight line, x is that. We are going to use the substitution method. Then from this curve, come and substitute for x. Then open brackets. Rearrange and get a quadratic which you can solve. So I've used the bulldozer method. Therefore y is 12 or y is negative 4. When y is 12, come back here and get the value of x. Still when y is negative 4, come back here and get the value of x. So that means that one point can be Q and the other one is P. So if this is P, in this case this is P and this is Q. So length PQ will be given by that formula, and then you substitute, simplify to get the length. So here I've chosen to use this as P and this as Q, but still you can interchange and make P to be this and Q to be that. It is also okay. So now we shall go to section B. Section B, you are supposed to answer 4 questions, but because this is a revision, you shall answer all. So question 9 says, part A, a polynomial px is given by this expression, where qx is the quotient, ax plus b is the remainder. When px is divided by x minus 1, the remainder is 4. When it is divided by x plus 2, the remainder is 1. Find the values of a and b. That was part A. I think let's start with part A. So that is what we are given. So when divided by this, it means that x is 1. So come and substitute where there is x, we put 1. Sorry. Here you don't substitute, it is just 2x, but here you put. So we're going to put x here, here, and here. So when you put x here, 1, automatically the whole of this is 0. That's why you see this 0 here. When you put here 1, you get a plus b. But they told us in the question that the remainder would be 4. So rearrange to get an equation. Then when divided by x plus 2, x is negative 2. So come and substitute x here, x here, x here. So when you put negative 2 here, the whole of this becomes 0. That's why you say 0 here. And here it becomes negative 2a plus b, which is equal to 1. Because they told us the remainder is 1. Rearrange to get equation 2. Then solve them simultaneously. When I subtract, I'll come up with 3a equal to 3. Therefore, a is 1. Then substitute for a in equation 1 to come up with b equal to 3. So that was part A. Part B, Roman 1, expand this up to the 4th term. Then Roman 2, use the first 2 terms of the expansion to find the value of this. Correct to 2 significant figures. So you shall use the formula which is there in your logbooks. So this, it will be equal to this. How is it generated? The first term is this one here. The second term is good by getting this times the whole of this to give you the second term. Then the third term, first write the power, then reduce the power by 1. So reduce this one by 1. Negative a half minus 1 gives you negative 3 over 2. Then after that, come and get this one, put it here and raise it to the power 2 over 2 factorial. Then use the same procedure for the next. So we are going to first write these two terms. Then the next term will be got by getting this minus 1 to give you that. Then next, we shall get the whole of this and raise it to the power 3 over 3 factorial. So those are the 4 terms. We shall put there this plus dash 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 to show that it was continuing, the expansion was continuing. When I simplify, this is that, and this one is this one is this, and this one is that. Then for Roman 2, we are told to find the value of these two significant figures. So first use indices to raise the power negative a half. Then you should realize that here it is 1 plus this, and here it is 144 plus this. So I first factorize out 144, which is here, so that I remain with 1 here plus this over 144. Then this power affects this 144 to give you 1 over 12. Then this one reduced it to give you this. So by comparison, if I compare, this is that, implying that this should be that. Okay, then they told us to use only the first 2 terms. So remember that this one, which is this, was got by saying 1 over 12 times this. So 1 over 12 is here. Then this one will be got from this expansion. But they told us to use the first 2 terms, which is 1 minus a half times x power 4, which is that. Then from there, use a calculator and round off to the required significant figures. Then question 10 says, part A, solve the equation this for x ranging from 0 to 180 degrees. So let's start with that. So you first rewrite the equation. Then from there, realize that this is 2x, this is x, this is x. Therefore, you have to first put them in the same under the same angle. If I use double angle here, the whole of this is that. It would have been a half this, but this a half times 4 gives you 2. Even the same applies to this. It would have been a half this, but a half times 2 gives you 1. That is why there is nothing here. Then open brackets and collect like terms. When I open brackets, you realize that this and this cancels. Then this minus this is 1. Then this is that. Therefore, make cos 2x the subject to give you negative 0.5. 2x will have 120 and 240. Then x is 60 when I divide throughout by 2 to give you those as the values. That was part A. Part B says, show that if this is equal to that, then tan x is that. And hence solve the equation this for x ranging from 0 to 360. That's what was given. Then expand using compound angle formula. Divide throughout by cos x cos alpha. It will give you this. So This one divided by this, you realize that the cos alpha cancels, then sine over cos gives you the tan. Okay, then this divided by this, you realize that the cos cancels, cos x cancels, then sine over cos gives you tan alpha. Then this divided by this, cos cancels, then this over this gives you tan x. And this divided by this, the cos x cancels, remain with this over this to give you tan alpha. Then collect like terms, take this on this side and bring this on this side to come up with this. Tan alpha is common on the left hand side, so factorize it out. Even here, tan x is common, factorize it out. So in the question, they want you to make tan x the subject, so bring this on this side to come up with this, and that was the required expression. For the highest part, they want us to solve this. So what we are going to do, we are going to compare this. X is already there, alpha is 20 degrees, and P is 2. Now that I've known alpha and P, I'll come to this and substitute for alpha and for P. So P is 2, put it here and here. Alpha is 20. When I use a calculator, the whole of this will give me this, and therefore x will be that for the given range. Question 11 says, given that x is that and y is that, find the second derivative with respect to x. So I'll first get this one and differentiate it using quotient formula. So quotient means this one, keep this one constant, differentiate this, minus, keep this one constant, differentiate this, over the denominator squared. Okay, when I do that, next will be to open brackets for this and this. Then you simplify and factorize out t, which is common. Then for dy dx, dy dt still do the same. Keep this one constant, differentiate this, minus, keep this one constant, differentiate this. Everything divided by denominator squared. Open brackets and simplify. Then dy dx will use chain rule, dy dt times dt dx. dy dt is here. dt dx is the reciprocal of this. So this cancels. Then 1t cancels. You remain with 3t over t minus 2 minus t cubed. Then second derivative, you first differentiate this with respect to t and then multiply by the t dx. So when I differentiate this, it's a quotient, so keep this one constant, differentiate this, minus, keep this one constant, differentiate this, over denominator squared, times the t dx, which is the reciprocal of this. The next is to simplify. I'll come up with that. Then I realize that this and this gives you this cubed. There's another t here, put it there. Then this times this gives you that, because negative 3t cubed and plus 9t cubed gives you plus 6t cubed. Factorize out 6 to give you that, and you realize that this and this are the same, so it becomes cubed, and that's where you can stop. So differentiation, you have to simplify until you can't simplify anymore. Question 12, part A says, find this. Here we have to remember the laws of indices. This is the same as split the numerator, then apply the laws of indices. When this one goes up, it becomes a negative power. This and this cancels, remaining with only a half. Then to integrate, increase the power by 1, divide by the new power to come up with that. Then for part B, the gradient of the tangent at any point on the curve is this. The curve passes through the point this. Roman 1, find the equation of the curve, and Roman 2, sketch the curve and find the area enclosed by the curve and the line y equal to 0. So dy dx is that. Therefore, to get y, I have to integrate. When I integrate, I will get this with the constant of integration. Then at this point, x is 0 and y is 6. Come and substitute to get the value of c. Therefore, the equation they want, the equation of the line curve is this. Then for Roman 2, sketch the curve and find the area enclosed by the curve and the line y equal to 0. Sketching the curve, we need turning points. So dy dx is equal to 0. Equate this to 0. Then get the value of x. Get the corresponding value of y. Therefore, the turning point is that. We also need the nature, so shall get the second derivative. It is positive, meaning that the turning point is a minimum. Intercepts. When x is 0, come and substitute here to get y equal to 6. And when y is 0, substitute to get the two values of x equal to 2 and x equal to 3. Therefore, the intercepts are these ones. So I've got the intercepts, I've got the turning point and the nature, meaning I can go ahead to sketch the curve. So I need the axes and label them. Then draw the curve with a minima. Then put the necessary points, the intercepts 2, 3, and 6. Then the turning point. And that's what they wanted. Then they also wanted you to get the area. So area will be equal to integrating from 2 to 3 of this curve. When I integrate, I come up with this, substitute the limits, and use the calculator to get the answer. So it's a negative, meaning that the area is below the x-axis. Question 13, prove by induction that this is equal to this for all integral values of n. So let's start with that part A. So that's what was given. For n equal to 1, left hand side means the first term, which is 3. Right hand side means we substitute 1 where there is n to give you 3. So they are the equal, meaning it is true for n equal to 1. What about for n equal to 2? Left hand side means there are 2 terms to give you 11. Right hand side means we substitute n equal to 2 to give you 11. They are equal, meaning it is true for n equal to 2. Now next we shall suppose it is true for n equal to k. If it is true, it means that when you put n equal to k here, it will be equal to when you substitute for n equal to k this side. So note that you have supposed, because there's no way you can prove it. After that, we shall now try for n equal to k plus 1. N equal to k plus 1, right hand side, you just substitute. Where there was n, you put k plus 1 to get this expression. But for the left hand side, you add another term. From here, you add another term when n is equal to k plus 1. And that gives you this. So this from here, it was for n equal to k. Then n equal to k plus 1, you add another term where n is k plus 1. Then you have to simplify until you make it equal to the right hand side. So I'll come and say that the whole of this is this, because that's what we supposed in the previous slide. Then get LCM. Put everything and one LCM, meaning here it will be, they will put a 6 here. Okay. Then next you realize that this and this is common. So pull it out. So you have 1 over 6 and k plus 1. Then what is left is the whole of this, which is k times this to give you this, k times this to give you that. Then here you have k times this to give you this, and 6 times this, and also 6 times this to give you 18. Okay, then you shall collect like terms to come up with that. Then you shall look for factors whose product is 36 and sum is 13, and those are 4 and 9. Our aim is to factorize. So next I'll pair this one. The common factor is 2k, so pull out 2k, and I remain with k here and 2 here. Then for this one, the common factor is 9, pull it out, I remain with k here and 2 here. So factorize further, this and this gives you this, then this is common, gives you that. And when you compare with this, it is the same, meaning it is true for n equal to k plus 1. So now that it's equal to n equal to k plus 1, n equal to 1, n equal to 2, n equal to k, then it is true for all integral values. And that's what they wanted. For part B says, a man deposits shillings 150,000 at the beginning of every year into a microfinance bank, with the understanding that at the end of 7 years, he is paid back his money with 5% per annum compound interest. How much does he receive? So R is 5, P principal is that, and N is 7. So total amount is the summation of AN from N equal to 1 to N equal to 7, where A is the amount and is given by this formula for compound interest. That means that when this summation means you add, when N is 1 you get A1, N is 2 you get A2, out when N is 7 to get A7. So this means that I'm going to substitute for this N. A1 means N is 1, A2 means N is 2, A7 means N is 7. So when I do that, I'll come up with this. Remember R was 5. That's why I'm getting 0.05. So A1 put 1 here, A2 put 2 here, A7 put 7 there. And there's a P outside. So simplify to get that. So this one is a GP. So I'll use the formula for a GP, but there's a P outside, where A is equal to R and is equal to 1.05. So I'll come and substitute for P, then substitute for A, which is here, substitute for R, substitute for N, which is 7, substitute for R, then use the calculator to come up with the amount they wanted. Then question 14, part A says, if this is equal to K, where K is a constant, find y dx at the point that. So that is an equation we have to differentiate. So when I differentiate both sides, I'll come up with that and make the y dx to come up with that. Then you substitute. Remember that at this point x is 1 and y is 2. So come and substitute for x and for y to come up with this as the value of the y dx they wanted. Then part B, a rectangular field of area this is said to be fenced using a wire mesh. On one side of the field is a straight river. This side of the field is not to be fenced. Find the dimensions of the field that will minimize the amount of wire mesh to be used. So let x and y be the dimensions. So you come and make a sketch. So that is the river and that is the mesh with those dimensions. So area is xy, length times width, and they've told us it is 7200. Therefore y in terms of x gives you this. Okay, then the length of the wire is this plus this plus this, which gives you 2x plus y. When I substitute for y, I'll come up with that. Then I'll differentiate. This gives you this and this gives you that. So for minimum length of the wire, derivative is equal to 0. So come and equate to 0 and make x the subject. So I shall take the positive part because length is positive. Now that I've got x, we can get y, and after getting y, those will be the dimensions they wanted. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on marking guide for end of term 3 of math paper 2. So if you're not yet subscribed, please click the subscribe button below this video, and also if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.